In this video, we are going to see about the designing of common source amplifier. So let's get started. So initially, we take the devices NMOS transistor from devices MOS. So for common source amplifier, we are taking an NMOS transistor, and we are taking the sources from sources time domain. For VDD, we are taking VDC. We are placing it here, and for input voltage we are taking a sine input and we are going to place it here. So to move this text, press a function F5, and to move this we are moving it here, and we are moving it here. Yeah, and then we are taking a resistor load. Go to basic components, click resistor and place it in the load side of the NMOS transistor. Now we are going to connect this uh, with this insert wire. We are giving input to the gate. Drain is connected to the resistor, and another part of the resistor is connected to the VDD source, and we are going to connect it to the ground. So these are all for the ground connection. So ground is here. We are going to connect it. Another ground, another ground. So this is the connection for a common source amplifier. Now we are going to give inputs for the common source amplifier. The input voltage is, I'm giving it 700 millivolt, and frequency I'm giving 30 megahertz. Apply, click apply. You don't have to change anything for VDC and delay damping. You don't have to change anything. You just give input to the amplifier and give the frequency. Click OK. And resistor, I'm giving a resistor value of 10 kilo ohm. 10 kilo ohm. Okay, apply. And for VDD, I'm giving 1.2 volt VDD for this common source amplifier. Yeah, and I'm going to give the length and width. Length is 180 nanometer, and width I'm giving it 1 micrometer. Click apply. Okay, this is the inputs for the common source amplifier. But another thing in this simulation in this ADS tool is you have to give the name for this MOSFET transistor. So click open this NMOS parameter. You see there is a model name called MOSFET M1. So we have to give a name and give the inputs to this NMOS transistor, like what is the threshold voltage, what is the other parameters. So we have to give the input to the MOSFET transistor. So you have to add a model file, and what name in the model file you have to give it here. So we first add a model file. So you can download a model file from Google. So I have downloaded a model file, and this is the model file for 180 nanometer. So what is the name here is NMOS. So we are going to give the name of the MOSFET transistor as NMOS. So we first add the netlist file. So this is the netlist file for 180 nanometer. I downloaded from Google only. So we have to add this netlist file. So in order to add, you click a dynamic link, add netlist file include. So we will get a so you have to place it anywhere in the simulation window. Yes, simulate. You have to double click, and you have to include the model file. So click include files. You have to browse it. So add a 180 nanometer model file. Yeah, it has been added. So go click apply and okay. So what name is in the MOSFET and the netlist file? It is NMOS. So you change the name of the model file as NMOS. NMOS. Okay, I have given the length and width and model name of the model file. Click apply and okay. Okay, we have given the inputs, we have added the netlist file, but in order to simulate we need a simulator. So in ADS software we have different types of simulators. So we are going to perform a transient simulation. So click transient, place it here. Yeah, the simulator has been added. Now we are going to check the input and output. So we have to name the input and output. So to name it, to name the input and output node, click name, add it here. V in is the input we are going to analyze, and V out. Yeah, we have added the nodes for the input and output. So we are going to analyze this input and in the output. So to run, click this wheel button to simulate. If you have given the inputs correctly, simulation window and output window will pop up like this. And to now analyze the output, click this rectangular window and place it here. It will ask for the inputs to the output window. So we are going to analyze the input and output now. So we click we add input, and then we add output. So yeah, okay. You see, this is the red color is the input and this blue color is the output. We have given a 700 millivolt. So you can see the input and output in a separate box. So double click here. Instead of this rectangle, click this and press OK. So now you can see clearly. This is the input voltage V in, and the common source output voltage will be V out. So based upon the inputs, this V out will be changing, and this is the transient analysis. So for DSG analysis, we'll see in the next video.